Trigonometry. We will start trigonometry with the trigonometric ratios, the sine and the cosine and the tangent. Sine, cos and tan, these are the trigonometric ratios, and we use these ratios in right-angled triangles. Now, right-angled triangle is any triangle in which one angle is equal to 90 degrees. For example, in this triangle over here, this angle is equal to 90 degrees. It is a right-angled triangle. That means we can use the trigonometric ratios. So sine, cos and tan will only be used in triangles that have a 90-degree angle. First, you need to learn how to name the angles and sides of a triangle. Look at this triangle over here. This corner of this triangle is a vertex. This corner is also a vertex, and this corner is also a vertex. So a vertex is a corner of a shape. A triangle has three corners. That means triangle has three vertices. Now we can give names to these three vertices, A, B, and C. And we can call this triangle ABC. In triangle ABC, this angle can be called angle A, as it is at the vertex A of the triangle. And this angle can be called angle C, because it is at the vertex C. And we don't need to give a name to this 90-degree angle, but we can call it angle B. Now in the questions in the exam paper, you will see angles like these. Angle ABC, angle DEF. Now what does that mean? In this triangle PQR, look at this angle, angle P. If we move to one side of P, we get Q. And if we move to the other side of P, we get R. So P is between Q and R. And that is why we write P between Q and R, and we call it angle QPR. In the same way, this angle R is between P and Q. So that is why we write R between P and Q, and we call it angle PRQ. So whenever an angle is written like this, angle RST, you know that the angle is at S. Angle ABC, the angle is at B. Now to use sine, cos and tan, we need to know three things: the hypotenuse, the opposite, and the adjacent. Let's understand them one by one. First, the hypotenuse. In a right angle triangle, first find where is the right angle. When you see the right angle, the side opposite to it is the hypotenuse. It is the longest side of the right angle triangle, and we mark it capital H for hypotenuse. In this triangle, this is the right angle, and so the opposite side to this right angle is the hypotenuse H. When you know which side is the hypotenuse, after that you need to find out the opposite side. Opposite to what? In this triangle, this is the right angle, and so the side opposite to it is the longest side, the hypotenuse H. There are two more angles in this triangle. Suppose we want to apply sine, cos and tan on this angle, angle A. And the side opposite to angle A is this side. So we will mark this side as the opposite O, because we want to apply sine, cos and tan on angle A. But if we want to apply sine, cos and tan on the other angle, angle C, then we will mark this side as the opposite, because this is the side opposite to angle C. That means the opposite side will depend upon the angle on which you want to apply sine, cos and tan. Once you have the hypotenuse and you have the opposite, then you need to see which side is the adjacent. Now obviously it will be the remaining side. Look at this triangle PQR. Q is the right angle, and so the side opposite to it will be the hypotenuse. We mark it using H for hypotenuse. Now if we want to apply sine, cos and tan to this angle, angle P, then the side right next to it will be the adjacent side, capital A. And obviously the side opposite to it will be the opposite O. And if we want to apply sine, cos and tan to this angle, angle R, then the adjacent side will be the side right next to it. we will mark it as capital A, and obviously the opposite side to this angle R will be the opposite O. Now you understand that the opposite and the adjacent sides depend upon the angle on which you are applying the trigonometric ratios. Now let's start using sine, cos and tan. First, I want you to memorize this. SOHCAHTOA. Now what is the purpose of SOHCAHTOA? We use SOHCAHTOA to make equations like these. From SO we get S equals O divided by H. From Ka we get C equals A divided by H. And from TOA we get T equals O divided by A. And that means sine of any angle is equal to opposite divided by hypotenuse. Cos of any angle is equal to adjacent divided by hypotenuse. And tan of any angle is equal to opposite divided by adjacent. Now that is the purpose of SOHCAHTOA. Now let's use SOHCAHTOA to apply sine, cos and tan. In this triangle ABC, C is the right angle, and so the side opposite to it is the hypotenuse H, which is 13 centimeters. Now the opposite and the adjacent sides will depend upon the angle we use. Let's say we are using this angle, angle A, which is 24 degrees. And so the side opposite to this angle will be this. Let's call it small letter A because it is opposite to angle A. And so this will be the opposite side, O. From SOHCAHTOA you know that S equals O divided by H. And that means sine of any angle is equal to the opposite divided by the hypotenuse. Now we place the values for this triangle. Sine 24 is equal to the opposite side, which is A, divided by the hypotenuse, which is 13. We have made an equation using the sine ratio. Now let's use the other angle to do the same thing. If we use angle B, that is x degrees, then the opposite side will be this one. Let's call it small letter b as it is opposite to angle B. And side B will be the opposite O. Using SOHCAHTOA, S equals O divided by H, we can write sine of angle X equals the opposite side, that is B, divided by the hypotenuse, that is 13 centimeters. Now at the moment we are not concerned with solving these equations. We just want to learn how to use SOHCAHTOA. Let's apply the cos ratio or the cosine ratio. In the same triangle ABC, let's apply cos on this angle, angle A, that is 24 degrees. Now using SOHCAHTOA you know that C equals A divided by H, and that means cos of any angle is equal to the adjacent side divided by the hypotenuse. Now the adjacent side to this angle, angle A, is this side, the side that is right next to it. We mark it as capital A, adjacent. So the cos of angle 24 degrees is equal to the adjacent side, that is side B, divided by the hypotenuse, that is 13 centimeters. Again, we are not worried about solving these equations, we are just practicing how to make these equations. If we use the other angle, that is angle X, then the side adjacent to it is this, side A. Using C equals A divided by H, we get cos of the angle X is equal to the adjacent side, that is side A, divided by the hypotenuse, that is 13 centimeters. Now we will not be able to solve this equation because it has two unknown values, X and A. And this will help you decide which ratio to use in a given triangle, sine, cos or tan. If an equation contains two variables, two unknown values, you will not use it. You will only be solving equations that contain one variable or one unknown value. Now let's apply the tangent ratio or the tan ratio to the same triangle. Using SOHCAHTOA, we know that T equals O divided by A, and that means tan of any angle is equal to the opposite side divided by the adjacent side. If we apply tan on this angle, 24 degrees, then the side opposite to it is this, side A. and the side adjacent to it is this, side B. So tan of angle 24 degrees is equal to the opposite side, that is side A, divided by the adjacent side, that is side B. If we apply tan on angle X, then the opposite side will be this, side B, and the adjacent side will be this, side A. So tan of angle X is equal to the opposite, that is side B, divided by the adjacent, that is side A. Now we know how to make equations for sine, cos and tan. So let's start solving these equations. The first problem gives us triangle PQR, and it tells us to calculate the length of side PQ, that is this side between P and Q. Now first of all, this is the 90-degree angle, so mark the side opposite to it as the hypotenuse, capital H. Now you have to calculate the length of the side PQ, that is this side between P and Q. Can you see this side is adjacent to the angle of 34 degrees? If we use the 34-degree angle, then the adjacent side to it is side PQ. So we mark it as A for adjacent. So we have to calculate the value of adjacent A, and we are given the value of the hypotenuse H. A and H. From SOHCAHTOA we see that A and H come together in cos. So we can use C equals A divided by H. And that means cos of the angle 34 degrees is equal to the adjacent side, that is the unknown side PQ, divided by the hypotenuse, that is 15 centimeters. We rearrange this equation to get PQ equals 15 multiplied by cos 34, and that is 12.4 centimeters. The next thing we have to calculate in the same triangle is the length of the side QR, that is this side between Q and R. Now you can use the Pythagoras theorem to calculate it, but at the moment we are practicing the trigonometric ratios, so let's stick to sine, cos and tan. Now if you use the angle 34 degrees, then the side QR is opposite to that angle, so let's mark it as O for opposite. We have to calculate the opposite O, and we have the value of the hypotenuse H. O and H. From SOHCAHTOA we see that O and H come together in sine. So we use S equals O divided by H. That means sine of angle 34 degrees is equal to the opposite, that is the side QR, divided by hypotenuse, that is 15 centimeters. Rearranging will give us QR is equal to 15 multiplied by sine 34 degrees, that is 8.4 centimeters. Now let's do the same part again using tan. Look at this side PQ, that is adjacent to the 34-degree angle. So we mark it as A for adjacent. And the side QR is opposite to the 34-degree angle, so we mark it as O for opposite. Now we have to calculate the opposite O, and we have the adjacent A. O and A. From SOHCAHTOA we see that O and A come together in tan. So we use T equals O divided by A, that is tan of angle 34 degrees is equal to the opposite, that is QR, divided by the adjacent, that is 12.4 centimeters. Rearranging will give us QR is equal to 12.4 multiplied by tan 34, which is equal to 8.4 centimeters. In the problems we solved up till now, the angle was given to us. Now let's see how to use sine, cos and tan when the angle is unknown and we have to calculate the value of the angle. Look at this triangle ABC. In this triangle we have to calculate the value of angle ACB, that is this angle. First of all, the side that is opposite to the 90-degree angle is this, so we mark it as H for hypotenuse. And we know that the value of hypotenuse is 20 centimeters. And this angle that we have to calculate, let's call it X to simplify things. The side that is right next to angle X, this adjacent side, is given to us as 17 centimeters. Let's mark it as A for adjacent. Now we have the adjacent A and we have the hypotenuse H. A and H. From SOHCAHTOA, we see that A and H come together in cos. So we can use C equals A divided by H, and that gives us cos of angle X is equal to the adjacent, that is 17 centimeters, divided by the hypotenuse, that is 20 centimeters. Now, how do you calculate the value of X? Think about this. You have an equation x squared is equal to 17. To calculate the value of X, you take square root on both sides. On the left side, the square and the square root will cancel out, leaving behind just X, and on the right side, you will get under root 17. In the same way, to remove cos from the left hand side of this equation, we take cos inverse on both sides of the equation. On the left side, cos and cos inverse will cancel out, leaving behind just X, and on the right side, you will get cos inverse of 17 divided by 20. If you use the calculator to evaluate it, you will get X is equal to 31.8 degrees. Now that is all for trigonometric ratios in right-angled triangles. In the next lecture, we will learn what to do when the triangle does not have a 90-degree angle. We will learn to use the sine rule and the cosine rule. Until the next one, take care.